the first thing that we have to talk about is energy, right? The various forms of energy. So let's quickly do the vocabulary part here, that what all are we going to talk about in this particular unit. Different ways to transfer energy. So now we have talked about this, that when we say energy is being transferred, that obviously implies someone has a debit and the other system has a credit of energy. Sankey diagrams, where we are wanting to talk about these diversions of energy that we were just discussing, right? Hello students, welcome in today's class. In today's class, we are going to talk about two main topics of this unit, that is energy, work and power. The two topics that we are going to discuss is power and energy resources. So this is the third class of this unit, and in the first class we have talked about the basics, like what do you mean by energy, what do you mean by work done. In the second class we had talked about energy transfers and related terms, right? So in this class we have to discuss two main topics. We'll start one by one. So the first topic of this today's class is power. So without wasting any time, I think we shall move forward. Put down the heading power. All right. So now what do you mean by power is what we have to discuss. See, I will come up with an example, a very simple example. Let's say there are two students, A and B. Okay. Both of them have same mass, that is, let's say 65 kilogram hypothetically. And if let's say they are instructed to carry a 2 kilogram brick from the first floor of their building to the 5th floor. Okay. So both are given the same task, they both have the same mass, and the difference is that while the person A has been told to do this task in 3 minutes, all right, so from the first floor to the 5th floor in 3 minutes, while the second person can do that in 10 minutes, all right. So imagine both the students now. One is rushing up because he or she has to, do the task within 3 minutes, and the second student is doing it like at a slower pace with ease because he or she has a time of 10 minutes. Now my question, who is going to do more work? Who is going to do more work, student A or student B? Think about it. Now let's say if your answer is student A or if your answer is student B, then all of you are incorrect, and the answer is both will do the same work. So there's no difference in the work that they do, but the difference is in the fact that while A will do that work very rapidly, B is taking more time. So same work, A is taking less time, B is taking more time. So the rate of doing work is more for A and less for B. That is power for you. So power is basically the rate of doing work. Okay, what is power? Rate of doing work. So let's start with that. It means the rate at which you do work, or we can say how fast you work. How fast you work, all right? And when you do work, basically you're transferring energy, right? So you can also call it as the rate of consumption of energy. Rate of consumption of energy. I can come up with one more example. Let's say you have an air conditioner and you have a fan, and both are operating. So if I may ask, who is consuming more power, means who is rapidly consuming energy? So the answer is going to be the air conditioner. Air conditioner consumes more energy in lesser time, while the fan will still consume lesser energy in that time. So that is power also for you, that it is the rate at which energy is transferred or the rate at which the work is done, right? What should be the unit? So if you just follow the basics, that power is going to be proportional to the work, but at the same time inversely proportional to the time. So power is going to be work upon time. So what should be the unit? Since work is joule and time is second, so the unit should be joule second inverse, isn't it? The unit should be joule second inverse, which we also call watt. Okay, so do remember that the unit of power is joule per second or joule second inverse, or we also call it as watt, denoted by uppercase W. All right. So that's power. Power tells you the rate at which work is done. So don't mix it up or don't confuse it with work done. It is the work done per unit time. To put it in simple words, it is the work done per unit time. And therefore we have efficiency also being defined in terms of power. So let's say if I was talking about the fan, and if I tell you that the fan has a power rating of 50 watt, that means it consumes 50 joule per second of electrical energy, but it won't be able to produce that much of kinetic energy or mechanical energy by rotating. As we know, every device has some efficiency. So we can define efficiency as the useful power output to the power input. So for the case of fan, the kinetic energy per second is the power output and the electrical energy consumed per second is the power input. Needless to say, if you have to express it in percentage, then multiply it by 100, all right? So that's power for you, work done upon time, energy transferred per unit time, all right? You copy this down, then we move forward. All right, so you've paused the video, I hope, and copied down the stuff. Let's do a question straight away. A car of mass 800 kilogram accelerates from rest to a speed of 25 meter per second in 10 seconds. What is its power? All right, so what is car doing here? It's gaining energy, right, in the form of kinetic energy. So let's calculate the kinetic energy as we know the formula already from our previous classes. So again reminding, this class will only make sense to you if you have watched the previous classes of this unit, because it is in continuation with that. Okay, so it doesn't make sense if you are straight away watching this class, then it's my recommendation you go back to those classes and then come back to this. Okay, so kinetic energy is going to be half times m, that is 800 times 25 square, without a doubt, because the formula that we are using is half mv square. Okay, so let's do this calculation very quickly. So this becomes 400 times 625. Okay, and so let's do this calculation very quickly here. 400 times 625 is giving me 250,000. So 250,000. All right, so that's in joule. Okay, we can also write it as 250 kilojoules. Yes, easy. Now if we talk about the power, then that is going to be the energy change over time. So that is going to be 250 kilojoule divided by 10 seconds. So the power is basically 25 kilowatt. Okay, since we are taking energy in kilojoule, the power is also in kilowatt. Keep that in mind. So we can express the power of like heavier appliances, or where you're doing too much of work in lesser time, you can express the power in kilowatt. Okay, so that's an easy question for you. I hope you will be able to do such questions. I will wait, you copy down the question and then we move forward. All right, the next one. A boy who weighs 550 Newton runs up 10 steps. Each step is 0.2 meter high. Calculate his power if he takes 5 seconds to run up the steps. Okay, at constant speed. So keep that in mind. There is no chemical energy converting to kinetic energy because the speed is being maintained. The only change that is being brought about is in potential energy because this person is climbing up. So what is going to be the potential energy? You of course should know that it is mgh, where m is the mass, g is the gravitational field intensity, and h is the height. So the mass times gravity is straight away given to us because they have given us the weight. So that's the value of mg, right? And what is the height? So you would say it's 0.2 meter high, but then it is 10 steps that this person is climbing. So let's multiply this further by 10 because of the 10 steps, isn't it? So what are we going to get here? So 550 times 2, that's going to be 1100, right, joule. Now if we talk about the power, then it is going to be work done or change in energy, whatever you wish to call it, over time. So that's going to be 1100 divided by the time, that is like 5 seconds. So that's going to be 220 watt. Easy, no big deal, just that I wanted to make you more familiar with this formula. So power is rate of doing work. Sometimes they might do vice versa. They can give us the power of any appliance and ask us the energy it will consume in some duration. For example, if I tell you that, let's say there is a bulb, okay, let's say there is a bulb of power rating 40 watt, find energy consumed, find energy consumed in 5 minutes. Okay, so we are being asked that what is the energy this bulb will consume in 5 minutes. So the answer now should be energy is equals to power times time, because power is energy upon time, so energy is going to be power into time. So power is going to be 40 as they have given us, time is going to be 5 minutes, that's going to be 5 times 60, because you don't forget that if power is in watt, that is joule per second, so the time has to be in seconds, right? So let's do this calculation very quickly. 40 times 60 times 5, and that's 12,000. Okay, so that's quite huge. So that's like 12 kilojoule. All right, so that is the energy it will consume. So it's a vice versa question now. They have given us the power and they are asking the energy it will consume. All right, so you copy this down, then we move forward. All right, next is a similar question now. A filament lamp rated at 60 watt converts 20% of its electrical energy to light energy. Calculate the quantity of light energy given off in 5 minutes. So what has changed now? The power rating is 60 watt, all right, but then it only converts 20% of that into the light energy. Rest 80%, like if you remember the Sankey diagrams, where we used to say, like, if this is the electrical energy, if this is the electrical energy, then only 20% of it, only 20% of it, that is, let's say if this was 60 joule per second, so 20% of that is going to be 12 joule per second, and the remaining 48 joule is going to divert, right, into some other form. Let's say that is 48 joule per second, and that is in the form of heat energy or thermal energy, right? Heat energy or thermal energy, and this is the light energy. So the light energy is only 12 joule per second or 12 watt, and what they are asking now is that, you know, how much light energy is given off. So they are only talking about this. So the output power is 12 joule per second, isn't it? And we have to calculate the energy. We are again applying the formula that we had just learned, that is power into time. But the power that we are going to use is now only going to be 12 and not 60, because they are not asking the electrical energy that is being consumed. Had that been the case, then we would have multiplied 60 instead of 12, but they are asking the light energy. Okay, so now the time is again 5 minutes, so convert that to seconds. All right, so that's going to be 12 times 5 times 60. So 12 times 5 is going to be 60, and 60, so that's going to be 3600. Don't forget the unit is going to be joule. The unit is going to be joule, because we are multiplying joule per second with seconds, so that is like joule. Okay, easy. You should be able to understand what is power, and both the set of questions where energy is given and power is being asked, or power is given and energy is being asked. Copy this down, then we move forward. All right, so the next question, okay, the questions are like the basic questions are done for this, but then we will be, as you know, we will be coming up with a series of questions where we are going to discuss the past question papers, and we are going to discuss like topical questions of the past papers. So that is where you actually apply the knowledge that you will gain from these classes. So the basic questions I have talked about, like this is the set of questions you can get. Now let's talk about the energy resources, right? So what are energy resources? We have talked about, you know, energy has to be studied in two parts, right? First is energy as a resource or type of energy, and the second is energy transfer, right? So we have our energy needs. We are needing energy. We are in a way slave to energy now. We need energy for everything, right? So think about it, like what is the resource that's providing us with that energy? So if you go like thousands of years from today, you go back in time, then you would say that primarily it was wood. So wood was being burnt, and using that wood, human beings were using that energy maybe for cooking or heating purposes, right? That was the major two things where energy was needed, and it was wood that primarily human beings were relying on. But what happened then? Maybe in the recent 200 years or so, human beings came up with the idea of fossil fuels, where fossil fuels are basically like petrol, diesel, kerosene, natural gas, right? So all these are being used now recently from the past 200 to 50 years. Now if you look at the latest 50 years, then there has been a tectonic shift, there has been a tremendous transformation, and we have started coming up with many renewable sources of energy as well. So we will discuss about each one of them one by one, mostly in detail, and majorly discuss about the advantages and disadvantages, or pros and cons of each of them. Okay, so let's first take the names. Fossil fuels, we already have talked about it. Biofuels is like another way we are harnessing the plant's stored energy, but it is like recent plants, while fossil fuels are made up of plants and algae that has been there millions of years ago. So that is the major difference. In fossil fuels, these are the plants and algae resource that were like millions of years ago, and through a lot of processes it went through a lot of change, and that stored in them as fuel. So that is the difference. While biofuels is the recent plants that we grow, if we use them, then that is called biofuels. Hydropower is like harnessing water's energy, right? We will discuss about that. Geothermal energy is about the heat energy resource inside the earth itself. Then is solar energy, which you of course do understand is the main source for us, sun's energy. And the next is nuclear energy, relying on the nuclear fuel. Okay, that is basically radioactive fuel like uranium and maybe hydrogen and helium. We'll talk about that, but you can just copy down the basic bifurcation that we are going to talk about. All right, so the next one is one by one we are talking about that, and it is mostly information rather than about understanding something. It's more of informative things. So that is why mostly the things I have written, and one by one I am going to discuss that with you. So examples of fossil fuels include petroleum, natural gas, coal and wood. Chemical potential energy resides within the arrangement of atoms and molecules. We do know that, but that has happened by the process of photosynthesis. Sun's energy is trapped in the plants because of the process of photosynthesis, then stored in the form of chemical potential energy. We burn the fuel and then use that again. So that is how the cycle is. When fuel is burned in the presence of air, the atoms and molecules rearrange through a chemical reaction. We have talked about it. This chemical potential energy is primarily transformed into the thermal energy and light, which are utilized for cooking, heating, and of course now what is the major thing that we do with fuel is transportation, like petroleum, diesel, all these we use in vehicles. Advantage, of course, widely available at large scale. So you don't have any issue with that whatsoever. Fossil fuels are readily available throughout the globe. You have petrol pumps, you have easy supply of fossil fuels everywhere. Relatively cheaper in cost of production. So since we are just using the fuel that is already made, so there's not much cost involved. It's just in when we are in a way not producing it, we are just extracting it. So it's the extraction cost that is basically that we are spending here. Maybe a filtration is also needed. So disadvantage, environmental pollution, there's no doubt about it. When you burn fossil fuel, a lot of carbon is added to the environment, causing global warming and other impacts, as there are other poisonous gases also involved, right? Produced during the burning contributes to carbon emission and global warming. And secondly, of course, it is non-renewable. That is the main disadvantage, that what happens is that when you are using petrol diesel from a particular reserve, you are obviously exploiting it and exhausting it. So ultimately it won't grow. It will take millions of years again to replenish that, and so that is why we will obviously consider it as a non-renewable source of energy, right? Copy down the important stuff, though we will be sharing the slides with you in the description, so you can obviously get it from there, or you can just pause the video and take a screenshot of this. All right, the next one is biofuel. So we have primarily, like the basics we have discussed. Examples of biofuels are ethanol, biodiesel and biogas, which are derived from biomass. Biomass comes from living materials such as corn, sugarcane, vegetable oil, plants, algae, but that are recently grown. Keep that in mind. Animal fats and animal manure also in a very limited amount are used to produce biogas. Keep that in mind. Chemical potential energy is stored in the biofuel. The chemical potential energy is converted mainly to thermal energy and light for cooking, heating and transportation. So that is a good idea, that biofuels can also be mixed with the fossil fuels, and they are being used in a way lowering down the pressure on fossil fuels. So biofuels is a recent invention in that sense, and now even vehicles and everything is being developed which can extract or work entirely on biofuels. So there is a lot of future in that. But you might wonder that environmental wise it is the same thing. You are burning fuel, you are producing carbon dioxide, but there is a catch here. Agreed, you are burning fuel and you are producing carbon dioxide, but think about it, when they are growing, they are also consuming the same amount, because when plants grow they consume carbon dioxide, and that is why in a way that effects nullifies. So when you're growing a plant, it's consuming carbon dioxide. When you're heating it, when you're burning it, it's giving out. But have you effectively added any carbon dioxide? Almost no. So in that sense, they are better as compared to fossil fuels as far as environmental impacts are concerned. But you might argue here as well that when you are growing plants, when you're growing this sugarcane, etc., whatever it is, you are needing a lot of land, which you might get by burning forests or cutting down forests. Then it has a negative impact. So if you're doing that by cutting down or burning down forests, then obviously it is a loss in that sense. Okay, so environmental pollution from the so first let me talk about the advantage. Widely available at a large scale, relatively cheaper in cost of production, renewable energy resource. So keep that in mind. This is the main highlight. While fossil fuels were considered non-renewable, these are going to be renewable. We can grow them again once we use them. Environmental pollution from the gases produced during burning contributes to global warming. That's the only disadvantage, but I have told you it's not that much as if you compare it with the fossil fuels. Copy this down, then we move forward. All right, the next one, hydropower. What are we doing here? Hydropower is basically in a way using water's energy. Now how would you do that? So the first thing that you can think about is by constructing dams. So when you construct dams, you keep storing water, you keep collecting water, it rises in potential energy, right? So when it rises in potential energy somewhat like this, and you can then flow it through a slope, make it flow through a slope, and then use that to rotate turbines. So those turbines have a capacity like a generator. It's a generator arrangement where the kinetic energy of the water, flowing water, turns the turbine that operates a generator and produces electricity, which is the favorite energy out of all the possible options, because that looks clean, that is very convenient to use, and can be easily transformed to various forms. So in that form it is very versatile. So anytime if we can think of converting any resource into electricity, then nothing like it. Even now electric cars are there, electric buses are there, electric trains are there. So we are majorly using electricity also as a as a fuel of transportation. So in that sense, using water to produce electricity is what hydropower is. But then there is a problem. Like there is one way like this. First let me discuss another way, is through tides. So tides also can help us to harness water's energy. You do understand what tides are. So when there is a high tide, we can collect water, use the potential energy of water to convert that to kinetic energy, and then rotate the turbines over there. Okay, so let me read it out to you. Water movement provided power to spin turbine to generate electricity. This hydropower or water power can be obtained from ocean water, tides, and water behind hydroelectric dams. Next, water behind hydroelectric dams has gravitational potential energy. This is converted to kinetic energy, letting it flow downward. The flowing water will cause the turbine to spin. As the turbines spin, the kinetic energy of the turbines is converted to the electrical energy, as I have just talked about. Advantages, disadvantages, think about it yourself. Clean method, not really, because there is a catch now. Like hydropower plant, if we talk about, then electricity is clean. But let me tell you that there is another way of producing electricity is by thermal power plants, where what we do is we use a fuel, we heat up water, maybe convert that to steam after heating so much, and that high pressurized steam is then used to rotate the turbine. So that high pressurized steam, of course, that is the kinetic energy of the water or steam also, but that steam is produced by burning fossil fuels. So if you are talking about thermal power plants, so you call them thermal power plants, where you are using either like coal, petrol, diesel or kerosene to heat up water, is not exactly clean. So their electricity is giving us a cost of on the environment. Keep that in mind. Renewable energy resource, of course, yes. If we talk about the hydro power plants like this, then it is a renewable source of energy, because it is relying on rain or tides, which renew every time, right? So in that sense, hydropower plants are all good, but I have told you that electricity overall you cannot assume to be clean, but if it is produced by hydropower plants, then it is clean. Okay, but this disadvantage, obviously constructing a dam arrangement and then the generator arrangement takes huge cost, because it is not small amounts of water, it is huge amount of water that has to be collected to produce substantial electricity. So high cost of building dams and turbines. Damming a river for hydroelectric power station may cause damage to the environment. That is of course true. If we are constructing a dam, then we are obviously disturbing the ecological balance of the river system over there. It will have its impact, and constructing dam might even cause a scarcity of water in some areas where the water was flowing. But if you construct the dam and restrict the flow of water to those areas, the people over there do get affected. So it has environmental impact in that sense. Okay, so you do understand what hydropower plants are. I will wait, you copy down the important stuff, then we move forward. Okay, the next one is geothermal energy. So now what is geothermal energy? So there is a huge amount of thermal energy or heat energy stored inside the earth. If you know that happened while the formation of earth took place. Some kind of extra pressure created that heat inside the core of the earth, or it might be also, or it in fact is also due to the radioactive fuel or radioactive substances like uranium inside the core of the earth. They continuously go under like radioactive decay and produce huge amounts of heat. So this huge amount of heat energy stored within the earth, we can harness that. How can we harness that? So maybe we will pass water through that, right? We will pass water through that and heat up water, maybe convert that to steam and then rotate the turbine, as I was telling you, that if you heat up water and convert that to steam, so that kinetic energy of the steam can rotate the turbine and produce electricity. But that's good, because we are not burning any new fuel. What we are doing is we are relying on the heat of a fuel that is already burning inside the earth. So it's just that we need to identify such what you call geothermal hotspots. So we need to identify such hotspots where we can easily understand that the heat is accessible, and we can get to that and circulate water through that, convert that to steam, just like the way hot springs work. So hot springs work on the same in the same fashion, naturally, that water comes in contact with hot molten rocks, and therefore it converts into steam, and it is very fascinating to see that steam is gushing out of the earth. So that is why it happens. In certain areas such as volcanic regions, geological forces push a large amount of hot molten rocks near the earth's surface. These places are known as geothermal hotspots. Water that makes its way through the geothermal hotspots is heated and subjected to great pressure. This heated water contains a large amount of thermal energy. It is forced to the surface as boiling water and steam to drive the turbines. Electricity is produced by generators connected to the turbine. Advantages: clean source. Of course it is a clean source. You are not burning any fuel further. Renewable energy resource. Of course, like mostly it is renewable, because the heat is continuously going on and on and on for thousands of years, millions of years, and it will keep going like this. So you can consider it as renewable resource, right? Environmental pollution caused by the release of poisonous gases such as hydrogen sulfide. So that is a very slight impact, but we won't call it extra carbon emission. Not widely available as they are, of course. So we don't find these hotspots everywhere on the earth, then it would have been very lucky of us, but it is only available at certain areas, so only there you can use that. Copy down the important stuff, then we move forward. All right, the next one is solar and wind energy. So there is no need to mention that the ultimate source of energy for us is sun. Even if the plants are storing it, even if they are the fossil fuels that the plants and algae have stored it over the millions of years, they are all energy of the sun. So we are not talking about the indirect way, we are talking about the direct way we can use sun's energy. So one such way could be, the sun's rays, they cause unequal heating of the earth, you do understand, and this unequal or uneven heating of the earth causes a wind movement across the earth, and very prominent in some areas. So when you have such a strong wind blowing, we can harness the kinetic energy of the air particles, which is basically the wind, to turn large turbines or large mills called windmills. And when they rotate, they are connected with a generator assembly, and that can be converted to electricity. So that is what windmills are, or wind farms are. Another way of doing it, which is very fascinating, is with the help of solar panels. So what solar panels do is just like what plants do in a way. They straight away take sun's energy, somehow have a mechanism to convert it into energy by the process of photosynthesis, let's say. Similarly, there are certain kind of special cells called solar cells or photovoltaic cells, which take up or traps sun's energy and straight away convert that to electricity. What more can you ask for? Converting sun's energy directly into electricity, no energy, like no environmental impacts that way, no pollution being done, and that is why this is the fuel of the future. So this is what you do. You construct solar farms, you put solar panels, they straight away convert sun's energy into electricity. All right. So solar energy comes from the sun. This energy is released in the sun by nuclear fusion. They are also talking about the main source by which sun is producing energy. So agreed, the radiation reach us, that is the way of energy transfer. But what is the resource of the sun's own energy? So the answer is nuclear fusion reaction, conversion of hydrogen to helium. That's continuously happening for billions of years now. So those billions of years, hydrogen is converting to helium, nuclear fusion reaction is happening, and energy is being released. Okay, solar energy can be converted directly to electricity. Solar cells are used to change solar energy to electrical energy by means of a photovoltaic cell. So what is the name? Keep in mind, solar cells, the photovoltaic cells. The infrared electromagnetic waves in the solar energy can be converted to thermal energy also. So we do rely on solar cookers, and we also sometimes have this mechanism where sun's infrared rays are focused on water and converted to steam. Now listen to this. Sun's energy straight away, concentrating sun's energy at a point and heating water to such an extent that it converts to steam and then rotate turbines. So this is another way. If you don't have photovoltaic cells, you can concentrate sun's energy by using reflectors, and those reflectors can, you know, heat up water to convert it into steam, and that steam can turn the turbine. So that is another way of doing it. And for heating, of course, solar energy is the source of wind energy. The uneven heating of the earth's surface results in the movement of warm and cold air. This produces wind. By means of wind electric generators, wind energy can be converted to electrical energy. Less polluting than fossil fuels, there's no doubt about it. Renewable, sun will shine every day, so we can rely on sun's energy forever. But there is a catch here. We do agree that it will shine every day, but then, you know, some days it might not shine that much. In the night it might not shine that much. You might not have wind throughout the day. So this is the drawback, that this is, you know, weather dependent. This source is weather dependent, and like in a way you can call it like it is weather dependent, so we cannot rely on it as a continuous source of energy. There's not a continuous source. So sometimes you know, we will get a good supply, a good power output, but then it might drop down. So that is why, you know, we don't rely on solar cells straight away, because, you know, what if we need energy at a particular point in time when the solar cells are not providing it? So what is the new way of doing it? Sun's energy, solar energy are converted to electricity and then made a part of the national grid. So it is made a part of the national grid, it is stored and then used as per need. Sometimes directly you use it, so maybe like in some watches or calculators where you use it directly. Keep that in mind. And obviously, needless to say, the International Space Station, the satellites, everything, they are, you know, if they are using electricity for some function, they are majorly relying on the sun's energy or the solar energy to meet their energy needs over there. So that is why solar energy is very, very, very important. Okay, uses a lot of space, that is true. Constructing wind farms, constructing solar farms, you know, it needs a lot of space, but the good part is that we can use the desert, and the desert areas are very like they are not very much usable for cultivation and stuff like that, so we can make use of them by constructing solar farms. All right, copy this down, then we move forward. Keep in mind all these advantages, disadvantages. That is where the questions come from. Nuclear fuels such as uranium are used to produce large amount of thermal energy. There's no doubt about it. There are two types of nuclear reaction we have discussed in the previous video: fission and fusion. Fission is like very unstable heavy nucleus break down into smaller nucleus and release energy. This energy is still something that we can harness, it's controllable. But fusion, the reaction that is taking place on the sun, is like, it's huge in amount and it's very difficult to control. So if we are using, think of it like that, if we are using nuclear fuel to heat water and then convert to that to, you know, steam, and then use that steam to rotate the turbines, just the way thermal power plants do it, but they do it with the help of coal, petrol and stuff like that. But here we are using uranium as a fuel to heat up water. So that's good. We are using uranium in a way like it has a very high calorific value. We can use very small amount of fuel and still produce large amount of energy. That is why nuclear fuel is also the fuel of future. We do use nuclear fuels to produce electricity at huge extent. So keep that in mind. But there is of course a drawback, that it releases harmful particles, radioactive particles, which are cancer causing and have devastating effect on the whole habitat or the population. So that is why it is a little like, in a way, like it has that drawback, and at the same time it is also very like hazardous in that sense. It pose a threat of a nuclear blast and stuff like that, which can cause a devastating effect on the whole population around that area. So in that sense it is a little risky, but now, you know, we are evolving and we are learning new ways to keep a good check on all those things. So risk of accidents and pollution from the improper disposal of radioactive waste. Non-renewable, of course, uranium is limited, and you know, it will in a way vanish one day, such nuclear fuel. But we do understand that if we are able to harness fusion, then maybe hydrogen is still available in a good amount. Then hydrogen if we are going to reach a level we are going to use fusion, then it's going to be way more beneficial. A low carbon energy resource which helps to reduce greenhouse gas emission that causes global warming. So of course it's not producing carbon, and it is rather producing heat in a different sense by causing nuclear fission reaction. Higher reliability in supplying uninterrupted power. That's very important. You have sufficient amount of nuclear fuel and the nuclear reactor can keep going on and on and on, maybe for a year. So that is why you can rely on it as a continuous supply of energy. All right, so you do understand what is nuclear fuel, what is nuclear energy. We are mainly using nuclear energy to produce electricity in what are called nuclear power plants. Okay, copy this down, then we move forward. Yeah, but needless to say, in a way, if we are saying that sun's energy is the main source of energy, but that also is relying on its energy by the help of nuclear fusion. So that is how nuclear source is very important. Our main source of energy is the sun. Just to again revise, other than geothermal, so keep this in mind, geothermal is not relying on sun, of course, nuclear is not relying on sun, and tidal energy also we take it as because of the moon, right? So that these are the three energy resources which do not rely on the sun directly or indirectly, right? Then solar energy is the source of wind energy. We do know that solar energy is converted to chemical energy in plants through photosynthesis, and that is why fossil fuels and biofuels, all these are also in a way solar energy. Solar energy plays an important role in water cycle, and that is why water rises up and then rain comes back, and that is how you store water behind the dams. So again, in a way, lifting up water is again provided by the sun. So in a way, hydropower plants also have, they need to be given credit to the sun's energy. So the only three sources that we will mention here is geothermal, nuclear, and tidal, which do not directly or indirectly depend on the sun. Next, we should talk about renewable and non-renewable sources of energy. So most of the energy supplies we use are fossil fuels, coal, oil and gas. There are limited reserve of these, so that if we continue to use them, they will one day run out. They are described as non-renewable. Once used, they are gone forever. Other sources of energy such as wind, solar and biomass are described as renewables. This is because when we use them, they will soon be replaced. The wind will blow again, the sun will shine again, and after harvesting a biomass crop, we can grow another one. Right? So there's no doubt about it. I have already talked about whether you categorize any resource as a renewable resource or a non-renewable one. Let's do a couple of questions, and I think we have covered all the resources, energy resources and power in this one, and I'm very excited. Then we'll come up with the previous year questions. All right. Next, which of the following energy resource is the odd one out? Nuclear energy, hydropower, wind energy and solar energy. So I think we should go with nuclear energy, because this is the odd one out, because it is not relying on the sun directly or indirectly, while the rest three are. Copy and complete the sentence that follow, filling in the gaps with words from the list below. An energy dash is anything from which we can obtain energy. So the answer should be an energy resource, right? That is the definition of energy resource, right? Is anything from which we can obtain energy. Most of the energy we use comes originally from the sun, of course. A dash resource is naturally replaced after we have used it. So the answer should be renewable, isn't it? Coal and other fossil fuels. Is there an option like that? Yes. Coal and other fossil fuel, right, are examples of non-renewable sources of energy, right? Energy carried by the dash can be used to turn turbines to generate dash. So energy carried by the wind can be used to turn turbines to generate electricity. That was easy. If you have watched the class carefully, this is all cakewalk for you. Last question we take, and that will be all. All right. So Fission and fusion are two nuclear processes that release energy, which is used in a nuclear power station. So answer is fission, right? What do? We use fission. What is the fuel used for this? So what is the fuel used for this? Like uranium and other radioactive isotopes. Uranium and other unstable isotopes, heavy isotopes. Why would we write that? Because heavy isotopes or heavy elements, they only go for fission, right? What is the sun's energy resource? So answer is fusion. What element is the fuel? Okay, hydrogen. Hydrogen is used, and that hydrogen converts into helium, isn't it? It converts into helium. What element is produced? Answer is helium. Here is a list of energy resources available to the world. Some of these are renewable and some are non-renewable. In the first blank column, put a tick by any two resources that are renewable. In the second column, put a tick that are non-renewable. So let's play it safe. Coal is non-renewable. Hydroelectricity, will take it as renewable. Nuclear energy is non-renewable. Oil is non-renewable. Solar energy is renewable. Tidal energy is renewable, and this is also. So I think we can put a couple of ticks. That's easy. That's all for this particular class. I hope you're learning well and you are investing your time in this, and I hope you find these videos that we are making for you really helpful for your studies. We will do the PYQs now. That's all for the theory class of this particular class, and I will see you next time. Happy learning. Bye bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.